Welcome back. I hope that your logging is going well. Becoming good lumberjacks with all your logs. So this is for section 5 of chapter 6. These are the properties of logarithms. There's going to be 4 main thoughts that we're going to work through on here. And so we're going to get started, jump right in. So these are going to be the properties. We're going to have the properties of exponents. We'll look at those. And then we're going to have the properties of logarithms. Now remember, exponents and logarithms, those are inverse functions, so they're very closely related. Remember, x equals log base b of m if and only if y equals log base b of n. Okay, so if you have those two, we have b to the x equals m, okay, blah, blah, blah. So remember, on the properties of exponents, if I have b to the x times b to the y, if I'm multiplying the same things down here, I have to add my exponents. So in the same way, if you're multiplying a part of a logarithm, you can expand that by saying, okay, if I have m times n, I can say log base b of m plus log base b of n. It gets expanded. Going this way is expansion using addition. Okay, notice it's a log of each of those. When we go this way, when we start with this and we come back this way, it's going to be called condensing. So you're going to have some questions later on that they will ask you to expand. So that's going to be using our properties to make this bigger, and then condense. So using our properties, something that's already big, to make it down into a single logarithm. Okay? So if you're multiplying your two parts, it gets expanded with addition. Okay, the quotient property, if I have b to the x over b to the y, that's b to the x minus y. You subtract your exponents, so the same thing here. Log base b of m divided by n is log base b of m minus log base b of n. So you have a quotient that gets expanded using subtraction. Okay, remember, things on the bottom are negative exponents. That's where that negative is going to come. Okay. So any log with a minus sign in front represents a value from the denominator when we condense it. So things from the bottom are things that represent a minus sign because it's a negative exponent. Okay. So that brings us to the favorite of mine. One of my favorite properties is the power property of logarithms. This is a bunch of fancy stuff. I call this the frog log because you get to make the frog jump over the log. And this is what makes exponential functions solvable in algebra terms. Okay, so if you have log base b of m to the n, this n right here, that is our frog, and we're going to jump it over the log. So this equals n times the log base b of m, just the m by itself, nothing else. So the frog jumps over the log, and now it's in front. Okay. So that's going to be how we solve logarithmic equations coming up in the next section. Okay, so use the properties of logarithms we derive to evaluate each logarithmic expression. Log base 4 of 16 to the third. This is a frog. This is a frog. We jump it over. This is 3 times the log base 4 of 16. So log base 4 of 16, what that is, remember, 4 to what power equals 16? Well, 4 to the second power is 16. So this is 3 times 2, so this equals 6. Log base 4 of 16 is the number 2. Okay, log base 3 of 81 to the negative third. Frog log it over the top, negative 3 times log base 3 of 81. Again, 3, this logarithm, 3 to what power equals 81. You can use your chart, your nth root chart, to help you with that if you need to. That's going to be 4. 3 to the 4th power is 81, so that's negative 3 times 4. And so we get negative 12 for this answer. Okay, you see the plus sign? We're going to condense this. We're going to condense it. Natural log, remember natural log has a base of e. Natural log of e squared plus natural log of e to the fifth. So if I have an addition sign, if I want to condense it, I have to say, okay, this is the natural log of e squared times e to the fifth. Okay, that's this one. We're going back. We have two things, and they're adding the logs, so we have to multiply those two. So if you're multiplying your bases, you add your exponents. This is the natural log. 2 plus 5 is 7 of e to the 7th. So that's 7 times the natural log of e. Now remember, any log, if your base equals the value that you have, if you have log base x of x, that always equals 1. There we go. Log base x of x always equals 1 if these two are the same. And that's what's happening here. Remember, natural log has a base of e. So natural log base e of e, that's going to equal 1, so that's just 7 right there. 7 times 1 is what that is. Okay, next one, we're going to condense it. Now this 2 here, we can't divide those yet because we have two of the same thing. So this frog, we're going to jump back on here. Yeah. So we get the natural log of e to the 6th squared minus natural log of e to the 5th. So you have a power of a power. You multiply your exponents. So that's natural log of e to the 12th minus natural log of e to the 5th. Okay, this is a subtraction. Subtraction gets condensed using division. Remember, anything that follows a minus sign will go on the bottom of a fraction. This is natural log e to the 12th over e to the 5th. You can subtract your exponents. That's natural log of e to the 7th, which we already had here, and that's going to equal 7 when we're done. Okay, because you take 7 times the natural log of e. Excuse me. Okay. Natural log of 5, base 5 is 75 minus natural log base 5 of 3. So this follows a minus sign. So we're going to say log, not natural log, sorry, log base 5 as 75 over 3. 75 divided by 3 is 25, so log base 5 of 25. So 5 to what power is 25? We'd get 2. And 2, there's a plus sign, so you multiply, so log base 4 of 2 times 32. So that'd be log base 4 is 64. So 4 to what power equals 64? That answer, I believe, is 3. Okay, so that's kind of a little bit of how we're using those properties. Alright, so here's the summary of those. The base, we know what a base is. Properties of exponents, we've covered that. There's your product property, quotient property, and power property. Let's put log base x of x equals 1. We know that one. Log base x of 1 equals 0. Anything to the 0 power is 1. Don't forget that one. And kind of those are the 5 main ones. There's some other special ones that come into play, but we're not going to cover those right now. This change of base formula, we're going to come back and hit that. I think I talked about that a little bit in another video. It's been a few days for me getting back to your videos, though. So as of this day, April 1st, no one's watched an Algebra 2 video on the YouTube channel yet. Hope you're working on your past assignments, getting caught up. Okay, don't get too far behind. Okay, where are we at? There we are. This is page 177. So in exercise 1 through 4, use log base 2 of 5, and we know that's approximately 2.322. Log base 2 of 12 is about 3.585, so that means 2 to the 3.585 power is 12. 2 to the 2.322 power is 5. To evaluate the logarithm. Now you notice our base is 2, so we can also include the fact that log base 2 of 2 equals 1. Okay? So how you do these is you have to make write this number using 5s, 12s, 2s, or 1s. The 1s can show up. We're going to see that in number 2 here. But basically, we want to write it using 5s, 12s, or the base number. Okay, so we can use the base number. So what that looks like on your assignment is here, like use log base 7 of 4, log base 7 of 12 to evaluate this right here. So that means you can use 4s, 12s, and 7s to rewrite the number 3. So you're like, okay, how can I get the number 3 using 4s, 12s, or 7s? You don't have to use all 3 numbers, but you have to use 2 of them. So you would just say, oh, I have to take 12 divided by 4, that's going to be 3, 12 over 4. Okay, so number 2, all of these look to be base 7, so 4s, 12s, and 7s. So you're writing each of these numbers here using 4s, 12s, or 7s. Okay, come back. So we want to write the number 60 using 5, 12s, or 2s. So you have to think about, okay, how can I get the number 60 using 5s and 12s? And we realize that log base 2, the 60, is 5 times 12. So 60 is 5 times 12. Take those two, multiply together. There's the multiplication. We can expand it. We want to expand that, so that's log base 2 of 5 plus log base 2 of 12. Now we know those values, those approximate values. Log base 2 of 5 is about 2.322 plus log base 2 of 12 is 3.585. We add those together. Get your calculator here. 322 plus 3.585. And we get 5.987. So it would be approximately 5.907. So 2 to that power should be about 60. So we can check that. 2 raised to the 5.907. That's pretty close. Okay, it's not going to be exact because these are approximations. That's how you check it. 2 to that power should equal that one. Okay, log base 2 of 1 over 144. So there's the 1. That shows up 144. How can I get that 144 using 5s, 12s, or 2s? And we need to recognize that 144 is 12 squared. So log base 2 of 1 over 12 squared, or 12 times 12. Okay, I'm going to use an exponent with this. So I have a division problem going here. So I'm going to expand it. Log base 2 of 1 minus log base 2 of 12 squared. So log base 2 at the top. The 12 squared came from the bottom, so I'm going to put that after a minus sign. I'm going to take this frog and jump it over the log. So log base 2 of 1 minus 2 times the log base 2 of 12. And now we're ready to substitute in. So log base 2 of 1, log of 1 is always 0, minus 2 times log base 2 of 12 is 3.585. So we're going to get negative 7.170. Yep. Oop, 1, 7. Don't need the 0 there, I guess. But so negative 7.170 would be that answer. And again, you can check it. If I take 2 raised to the negative 7.17, I get that, and if I do 1 divided by 144, I get the same value. We're really close to it. Okay, so that worked. Log base 2 of 12 over 25. So there's a 12. 25, we can use 5s. 5 squared. So 25 is 5 squared. So I'm going to say, okay, this is log base 2 of 12 over 5 squared. Try to keep my hand out of the way for you. So this is division. Log base 2 of 12 minus log base 2 of 5 squared. Make the frog jump the log. log base 2 of 12 minus 2 times the log base 2 of 5. So this is expanded now all the way. We substitute in our values. 3.585 minus 2 times 2.322 minus 2 times 2.322. We get negative 1.059. Okay, check that. I'm going to take 2 raised to that answer, and then 12 divided by 25. So 0.4799 and 0.48. Looks okay. Oh, a bigger number, 720. Okay, 720, 72. 12 goes into 72, so 12 is going to go into 720. 720 divided by 12 is 60. Oh, a 60. We already had a 60. So 720 is 12 times 60, so that's 12 times 12 times 5. So I have a 12 squared times 5 right there. So 12 times 60. 60 is 12 times 5. So I have two 12s and a 5. So this is rewritten as log base 2 of 12 squared times 5. So that's log base 2 of 12 squared. This is multiplication, so plus log base 2 of 5. Make the frog jump to log, so there's your frog. Whoop, ribbit. Alright. 2 times the log base 2 of 12 plus the log base 2 of 5. So that's 2 times 3.585 plus 2.322. So 2 times 3.585 plus 2.322. And we get approximately 9.492 for that value. Again, we take 2 raised to that answer, and we should get about 720. Really close. Alright. Tricky part there is sometimes knowing how to break those numbers up. Okay, so if you need help with that, shoot me what number you have, shoot me what numbers you can use. Not shoot me, but send me. I'll help you out. So expand the logarithmic expression. We've already been doing this a little bit. This is multiplication, so you just expand it log of 10 plus the log of x. Now look to simplify anything. So we've expanded. Can we simplify? So our base is 10. This is a common logarithm because there is not a number there. Our base is 10. So log base 10 of 10 would be 1. So 1 plus log x would be how that simplifies. Okay, natural log, 2 times x to the 6th. So that's 2 times x to the 6th. So that's natural log of 2 plus natural log of x to the 6th. Frog log it. Natural log of 2 plus 6, natural log x. Natural log has a base of e. There are no other e's showing up, so we'll leave it like that. Alright, here we get to some bigger stuff. X to the 4th over 3y cubed. So we get the log base 3 of x to the 4th minus log base 3 of 3y cubed. Now, when you expand this one right here, this minus sign has to go to both of those. Both of those came from the denominator. So it gets expanded log base 3, let's put the 4 in front, the frog can jump over, 4 times the log base 3 of x, minus log base 3 of 3, minus log base 3 of y cubed. So that minus sign distributes to both parts. Don't put a plus here. You're saying, hey, it's multiplying. It's going to be a plus. It's a plus in a parenthesis, but then you have to distribute that negative. So that's why I try to get in the mindset of anything that comes from the denominator will have a negative sign in front of it. Okay, so when you expand it, if it's following this minus sign, both parts will have that minus sign. Okay, notice the middle, log base 3 of 3 is 1, and we can do a frog log here. So we get 4 log base 3 of x minus 3 log base 3 of y minus 1 from the log base 3 of 3. Okay, radicals, convert those into exponential form. So this would be 3y squared to the 1/4 power. 3y squared to the 1/4 power. So I'm going to frog log that right away. So 1/4 times the natural log of 3y squared. Okay, when I expand this, that 1/4 will go to both of them. So it looks like 1/4 times the quantity natural log 3 plus natural log y squared. That is 1/4 natural log 3 plus 1/4 natural log y squared. The frog will jump over the log. 1/4 times 2, that multiplies. Times 2 would be 1/2. So we get 1/4 natural log 3 plus 1/2 natural log y. And that's where we leave it. Okay. Condensing the logarithmic expression, this just goes the other direction. So log base 2 of 3 plus log base 2 of 8. You're adding them, so you're going to multiply them. Log base 2 of 3 times 8. So that's the log base 2 of 24. I think that's going to be what they want there. 24 does have a 2 squared. Let me just check. 3. Yeah, that's going to be... Can simplify it, you can, but we'll leave it like that. That can stay there. Okay, log base 4 minus 2 times the log of 5. Log base 5 of 4 minus 2 times the log base 5 of 5. Okay, we're going to leave this. I know I see a log base 5 of 5. We're going to leave it like that right now. We're going to take this frog and jump it over the top. So we get to log base 5 of 4 minus the log base 5 of 5 squared. Okay, so this part's going to go on the bottom. That's log base 5 of 4 over 25. Over 25. So that's how you'd condense it. Leave it like that. Okay. 3 natural log 6 plus natural log 4y. So this 3 goes over the top. So we get natural log of 6x cubed plus natural log of 4y. So 6x cubed, 6 cubed is 216. So this is natural log of 216x cubed times 4y. Because you're adding it, you're going to multiply that. So 216 times 4 is 864. Natural log of 864 x cubed y. All that together. All right. Oh, big 3 parts. Okay. Natural log of 2, base 2 of 625 minus, there's a minus sign, so that's going on the bottom, plus 1/3 natural log 2 of 27. So I see this frog, I'm going to jump it up here first. So log base 2 of 27 to the 1/3 power. Well, 27 to the 1/3 power is 3. 27 raised to the 1/3, that is the cube root of 27, that is 3. So this part right here becomes 3. This is log base 2 of 3. So anything with a plus sign is going to go on top. So log base 2, 625 times 3 over 125. So 625 is positive. The 3 came from a positive. The 125 is a minus, so that goes to the negative here. Okay, so 625 times 3 divided by 125. How does that work out? 15. So that's the log base 2 of 15. Let's do that calculation. Okay, negative. Okay, negative log base 6 of 6. Okay, that negative is going to go. That's going to go on the bottom. Minus log base 6 of 2y, so that 2y will go on the bottom. And then we have 2 log base 6 of 3x. So here's my frog. Jump it over. 3x squared. That's going to be log base 6 of 9x squared. So this part's going to be on the top. This part and this part, those two are going to be on the bottom because they're following a minus. So it's log base 6 of 9x squared over 6 times 2y. So 9x squared over 12y, so we get log base 6, 9 over 12 is 3x squared over 4y. Okay, so 9x squared came from this one. It's positive, that's the only thing on top. 6 and 2y we had negative, that's the only thing on bottom. So 9x squared over 12y, and then 9 over 12 is 3/4. So I just reduced that. Okay, last thing is a change of base formula, and that is, we hit that real quick on the other one. That is this right here, saying if you have log base c of a, it's log base b of a over log base b of c. So a lot of times this new logarithm right here, the b value is going to be at 10, so we just use our log button. So that looks confusing. What it means is if you want to evaluate log base 3 of 17, you can just say, okay, that is the log of 17, common log of 17, over the common log of 3. Okay, we did that earlier. So log of 17 divided by the log of 3. Usually 4 decimal places, 5, 7, 8, 9. It doesn't matter if you use a common log or you use a natural log. You get the same answer. Okay, so that's all you're doing on those. This one, you're going to take the log of 294 over the log of 9. Make sure I put this in here. See if that changes it. You need to close that first parenthesis. 2.5867. It's going to be the log of 4/9 over the log of 7. So -0.4167. And finally, log of 1/10 divided by the log of 6. -1.2851. Okay, that's it. No word problems. Any word problems that would show up would just be plugging in and figuring out your answer. But we're going to call it good for now. That expanding and condensing can be kind of tricky at times, so I'll let you just work with that. But let me know what questions you have, and we'll see you soon. Good luck. Adios.